solve another Leetcode problem, 400 nth digit. So for this example, we are giving an integer n, so we're going to return the nth digit of the infinite integer sequence. So for example, the sequence is going to be like 1, 2, 3 until like 11 for this second example. So if n equal to 11, so this is going to be 1, 2 until 9. Yeah. And for this one, this is going to be the 10th digit, it's going to be 1. And the 11th digit is going to be this 0. So this is why we're going to return a 0. So for this 3, as we are only having 1, 2, 3, so the third digit is going to be 3. So for such kind of problem, normally there's no good ways to solve it. So why not we just simulate the problem? Let's just check what happens. Yeah. So for example, if it only has one digit, what gonna it looks like? So it's gonna be something like 1 to 9. So how many digits of them? It's gonna be 9. So if it is 9, it is 1 times 9. So it's equal to 9. It means that there are gonna only be 9 digits if there's only 1 digit numbers. So what if it is 2 digit numbers? So it's gonna be starting from 10 to 99. And how many numbers of them? So 0 to 99 minus 10. So 99 plus 1 minus 10. So it's gonna have 19 numbers. So for each of the number, it has 2 digits. So how many digits in total? It's gonna be 2 times 90. Yeah. So for 2 times 90, it's gonna be 180. Yeah. So now let's just check what happens from 100 to 999. So this means it's gonna be a 3-digit number, and how many in total? So it's gonna be 900. So this is gonna be something like from 0 to 999, and it's gonna be 1000. So for this 1000 minus 100, because for 0 to 99 it's gonna have 100 numbers, so it's gonna have 900 numbers. So it's gonna be 2700. Yeah. So according to this way, we should know that. So what happens if something like 1000 to 1000 to 49? Yeah. So it's gonna be the similar idea. So definitely it's gonna be 4 times 9000. Yeah. So according to this way, definitely we can count which number it is and which digit it is according to the given result n. As n is going to be a small number, maybe biggest it is less than 10 to the power of 9. So basically this means we can solve the problem easily. Yeah. So let's just use an example. Maybe this is 180. Maybe let's just use 191. So what about n equals to 191? So first of all, we're gonna minus this 9 and minus this 180. So minus 9 and minus 180. So what it gonna be like? Yeah. So if this n equal to 191, so this is 189. So it's gonna be 2. Yeah. So definitely it's gonna be a 3-digit number, and it's gonna be it's gonna be the second digit for this number, right? So what about this 3-digit number? Definitely it's gonna be 100 from the beginning, and then it's gonna be 101, 102. But since our n equals to 2, so what it's gonna be? It's gonna be at this position. Yeah. So if we turn all those numbers into the index, so we are starting actually from index 0. So this is the index 0, this is the index 1. Yeah, so this means it's gonna be the first number, and it's gonna be the index 1, and it's gonna be 0. Yeah, so we just need to understand how can we use some mathematical calculation to get the final result. So yeah, finally, if this n equals to 2, definitely we want to use n minus 1. This means 2 minus 1 is going to be a 1, because all the numbers, and for each of the numbers, each of the digits is going to be starting from index 0. So this is why we're going to do some trick. N minus 1, 2 minus 1 is going to be 1. And now, since this n equal to 1, we're going to use this this n equals to 1 to calculate which number it is. We're gonna use this n to calculate this number gonna be 100. And then we're gonna use this n to check which digit it is. As this n equals to 1, so 1 modulo 3, it is 1, it means it is this digit, it is 0. But how can we calculate that it should be 100? Why it's not 101? Yeah, because currently this n is just 1, so our final number is going to be 10 to the power of 10 to the power of 2. Yeah, so it's going to be 100, and then we're going to plus this number. This is going to be n divided by how many digits? 3. Yeah, so n is 1, 1 divided by 3, it is 0, so this is still 100. And then we're gonna use n modulo 3, 1 modulo 3 is gonna be 1, so it means it is this digit, it is 0. Finally, we're gonna return this 0. Yeah, now we're gonna use this kind of idea to calculate the final result. So basically, this is gonna be a mathematical problem. We're gonna prepare some current and base to check the final result of n. Yeah, because according to this way, so the current it means how many digit. Yeah, finally, and base we're gonna set it as 9 because we use something like 1 times 9, 2 times 90, 3 times 900, something like that. So current gonna be starting from 1 and base gonna be 9, and then we're gonna use a while loop. So while n minus current times base. So while it is more than 0, so we're gonna use n minus current times base. Now we can update the current gonna plus equal to 1 and base gonna times equal to 10. Now we get our final n, and for this n we need to do some trick minus 1. This is because all our index is just coming from index 0, so we're gonna do a trick n minus 1, and then we're gonna check this number. So this number gonna be 10 to the power of current minus 1. So in our example, for example, current equal to 3, 3 minus 1 is going to be 2, 10 to the power of 2, so it's going to be 100. And then we're going to plus this n modulo the current. So for my example, although I cannot find it, but you can check the previous recordings actually. So for example, it is 100, and we are checking 191. So finally, n gonna become 2, and 2 minus 1 is gonna become 1. So it's gonna be this number. How did we calculate that? This n is 1. 1 modulo the current is gonna be 3. 1 divided by the current is gonna be 3. So this number gonna be 100. Yeah. Next, we're gonna check the index. So the index is gonna be n modulo the current. Why we can do all those kind of calculations? That is because we use n minus 1. We are starting from index 0, because for this all divisions and modular calculations, actually it's starting from 0. This is why we're going to use n minus 1. So finally, we just need to turn the final result to integer and turn this num to string and find the index. Yeah, and this is going to be the whole solution. As you can see, basically it's just about simulation. We need to simulate such kind of problem and find the final result. Definitely it's going to be a good problem. Now let me just run it. As you can see, it works. Now let me just submit it to check if it can pass for all testing cases. As you can see, it's pretty fast and it passed all testing cases. Maybe we also want to analyze a little bit about the time complexity. Because here for this base is 9. Definitely this n number 9 to the power of 10 maybe this number, so this is a small value, maybe 01, but currently the calculation is 10, and for here this is just something like 01 calculation. Yeah, so basically the final time complexity is going to be 010 or 01. Yeah, I think that's all about it. Thank you for watching. See you next time.